Okay. Hello there, everybody. This is Genesis. It's officially March 18th, 2023. And today, I'm going to be coding. Again, it's March 18th, 2023. It is a Thursday. And it's 2 in the morning. It's about to be 2:30 in the morning. I'm gonna get into some actual coding now. Yeah, I'm back. It is officially if anybody's watching this in the future, the date is May 23rd. I'm sorry. It's May 23rd. No, I'm sorry. I'm sorry, guys. As you guys can tell, I'm really tired. It is May 18th, 2023. Now it's officially 3 in the morning. Hello. So, before I get into this stream, I want to talk about something that happened in my previous stream in case someone does look. But before we get into that, I want to talk about the documentation streams that we have right now. So, I thought it was going to be unfair to disable YouTube chat too. So I don't think that that's fair for everyone else or anyone who really does want to talk to me and learn something on stream. So good news. We have good news. The good news is that I'm going to leave the YouTube chat on forever. No matter what happens, I'm going to leave the chat on for you guys. We might get some people who might come in, but to clarify what happened in the last stream, someone made fun of me for speaking English and reading documentation. And it confused me at the time. It was very confusing. And I was going to disable chat forever, actually, because of this. But I changed my mind because I sat there and I thought about it for a little bit. This person is saying, so if we go to Chat GPT, I think there is a actual, we go here. And if anybody's writing in chat, I'm going to get to you right in a minute. We're going to break this down. I think it's this one, right? Yeah, but good morning. Good morning, everybody. Also, I got the premium version of Upbeat. So now I can play any type of music on my stream as long as it's from this website. So there's going to be way better music. No more ads. The ads are completely gone. I spent like $7. So that's good too. There's a lot of cool music in here and I made like a playlist and everything. But hello, Luther. Hello, anyone watching, you know. Yeah. So, we're going to read this. We're going to start all the way from the top. And I'm going to make this clear. I will have, yeah, so we're going to turn off the music for now. So, I asked ChatGPT, I asked him, someone came into my coding live stream and made fun of me and said how I envy you because you can speak English and read documentation in a good language. Why did this get to me? This got to me because if another programmer in the future looked at this situation, they would think, oh, well, this person knows more. And if you read documentation, you don't know anything about code. Right? It upset me because it made me feel like maybe a beginner out there. No, you want to read documentation. Trust me. Coding is based off of documentation. I mean, when we were children in the past, in preschool, how did you learn? Through documentation and reading books. That's how you learn. So I was very confused. I was sitting there thinking, okay, why is this person, you know, saying this stuff. And then it just occurred to me, guys, the guy just doesn't know what he's talking about. There's just some hateful people out there in the world. Should we disable everything because there's people who are hateful? No, we shouldn't. Truth is, the people that I talk to in my stream, like Luther, he's a very talented programmer. We talk about stuff on stream and we figure things out. And I honestly, without a shadow of a doubt, I honestly do think that whatever their name is, Tim, has no idea about anything about software development. Or if they do, they're feeding you guys the wrong information. So we go here, and this is their response, right? It seems that the person who made the comment was being disrespectful and trying to belittle you based on their assumption that English is a superior language. Guys, English is not the superior language, right? It's not. There's people who code in Spanish. There's people who code in all different types of languages. Japanese, Taiwan, all different types of languages. English is not the only superior language, right? We know this for coding and reading documentation. This is the part that hurt me the most because I was thinking, is it true if you read documentation, does it make you... No. Now, it's important to remember that coding and programming skills are not dependent on language proficiency alone. Many developers around the world excel in their respective languages, right? There's all different types of coders in the world. There's Japanese programmers and their code looks like all mangled up, And there are numerous successful programmers who code and document in languages other than English. So, unfortunately, some individuals may try to bring down others by using derogatory remarks or making comparisons. However, it's essential to focus on your own progress and not let negative comments discourage you. Guys, if I let every hateful comment get to me, you guys won't be able to talk to me. Like the people who genuinely like talking to me, you guys, if I let it get to me, I'll disable everything and then they win. So let's continue reading this. Remember that everyone has their own strengths and areas of expertise. Everybody has something they're good at in code, right? But to say that reading documentation is the wrong thing to do, that is like saying, oh, you're driving a car without gas. That's stupid. I mean, with gas, that's stupid. Or no, you're driving a car with a wheel. You're dumb. We need the wheel to drive. The information, coding is about downloading information constantly and trying to get that. Nobody can just download data from the air. It doesn't work that way. So I want to apologize to everyone for almost disabling YouTube chat. I mean, they've already done it over there on Twitch. I don't want to go to Twitch just because of that reason. But this is my final standing ground, is YouTube here. But I promise that from now on, if someone comes in and says something as silly as that, we are just going to ignore it and ban. So if you guys really do support me as a streamer, from now on, if someone is talking bad in chat, tell them to calm down, because we don't want to ban everybody, right? We want to make friends over here. We want to make, we want to meet other developers, So if you see someone acting up in chat, tell them, hey, dude, can you calm down? Like, we're all just trying to have a fun time here. But if they're just genuinely debating, I'm sorry, I think I'm getting sick again. Yeah. I'm going to go look at chat in a minute. I'm not looking at it right now because I have to get this out of my system. The streams will continue. Information will continue. But you guys have to hear me out on this. Reading documentation is how programmers learn. That's how people learn. It's okay to open up a book and read through it and study it over and over and over. That doesn't make you dumb. It doesn't. That guy has no fucking idea what he's talking about, which makes me believe that he's either one or two things. Not a programmer at all, or he is a programmer who just he's afraid of us taking his job. That's just the fact. He doesn't want us taking his job because he sees, people like me, my girlfriend, Mrs. Genesis, and Luther in stream chilling, learning so fast. He's like, oh my God, these guys are learning so quickly. There's people who fear that, So just remember that, guys, you are very powerful. There are people out there who will fear you and genuinely envy you. But then we go on to this part here. This is the last part. So I said, is there anything wrong with reading documentations? Is there anything wrong with reading documentation? And it said, reading documentation is an essential skill for any programmer or developer. Documentation provides detailed information about software libraries. That's true. Frameworks, programming languages, APIs, and various tools that developers use in their work. Here are the few reasons why reading documentation is important. So guys, do not let that comment get to you. I let it get to me a little bit. I haven't streamed all day because I was sitting here. I slept for 8 hours because I was thinking to myself, like, why would someone just attack me and make fun of me or just try to belittle me for no reason? And I came up with the answer. They literally don't they don't know what they're talking about, dude. Because guys, what do we do when we're always learning? Why do you go to school? You go to school to read documentation and to study. That's what it's. We are just dealing with a person who is just very hateful and hates their life and is going through something. And I hope that person feels better in the future. And yeah, unfortunately, they won't be able to come back on the stream because I banned them permanently because I don't want them polluting your mind. Guys, listen, I don't want that person or people like that polluting your mind. If you read documentation, you're dumb. You're not. Okay, so we're going to get over that pass, but here are the main reasons why documentation is important. Understanding functionality. Documentation helps you understand purpose, features, and functionality of a particular software or tool. It provides insight on, how, long story short, artificial intelligence, how it works, it actually has to fail over and over again, and it goes off of documentation and it studies over and over and again. In a way, we're like a artificial intelligence because we have neural networks in our brain with neurons that transmit data, and it gets better and better and better, and we get more intelligent as time goes on, right? But that's crazy. If that guy knew what he was talking about, he would have known that. But another reason why documentation is super important in the world of programming is because learning documentation includes guidelines and the best practices, that help you write cleaner code. So that's one. Another one is troubleshooting and debugging. But the most important one right here is keeping up with updates. As you guys know, programs do change, like, they have updates, do they not? We cannot just follow this guy rule. Okay, you have to learn something one time. That's it. If you don't know something one time, you're dumb. The world is constantly changing around us. There's always updates going on, and programs and software has, just because you learned version 1.1 doesn't mean that that's going to be how things are implemented in 1.2. Does that make sense? I feel so much better. I feel really much better, guys. This stream's going to be another 8-hour stream. But I wanted to get that out my system. I'm going to keep streaming. We're going to keep doing everything else. But it's going to be very simple. If someone comes into stream, we're just going to tell them, hey, I'm sorry you feel that way, but you need to tone down on the negativity, and if you keep it up, then I'm going to have to, you got to go. We're not even going to say that. We're just going to say, hey, can you just tone down on the negativity? We're trying to study. We're trying to learn. Because everybody who comes into my stream, you guys are trying to learn, right? We're all trying to learn and hang out and chill. That's all. We don't need someone coming in and telling us how to live our life. And as your content creator, I'm going to protect you guys, and I'm going to protect everyone who does come to my stream. And with that said, I think we can go read chat now. But let's read the last part. Overall, reading documentation allows you to gain an in-depth knowledge, improve your coding skills, and become more proficient in using various programming resources. It's essential. It's an essential practice that helps developers stay informed, solve problems effectively, and produce high-quality code. And that's the most important part. High-quality code. You want to produce code that works, you know? And, yeah, because just as much as he can say we read documentation, we could just throw back at him, well, your whole life is built on documentation. What do you mean? You've read books and documentation too. Just because you read more doesn't make you smarter than me. Just makes you more experienced. Yeah, I think that's it. I think I'm going to go open up chat now, and then we're going to turn on the music and continue stream. Yeah, but this website's really good with music. Let's see. Documentation is the most important to understand. Yeah, it definitely is. So guys, don't feel like it's tough out there, but I need you guys to hear me out on this one part. Let me put on notifications. I don't know why notifications is not working. Luther, you still there? You alive? Let me know if you're still there. I gotta know whether to turn this on or not. Well, how do I do this? Well, how do I turn this on? This thing gives me the worst. I'm alive. Okay. So what does this mean in the long-term goal of everything? Genesis is here to stay, but I want you guys to remember. Anybody who tries to bring you down, you are special to me and to the world. You have the power to make something really beautiful one day. And when you do, turn up the music. We're gonna get kind of emotional here. When you do, I'll be sitting there watching you as you grow. The world has monsters and good people and bad people. But remember to always focus on you. That's how you get better, you know? So with that said, let's go ahead and continue. Let's go learn. This music is good, isn't it? If you guys are wearing headphones, Luther, if you're wearing headphones, this music is fucking good. All right, let's see. I don't know why I'm not getting yeah, 3 types of persons, all types of people, but okay, now I need help how to here, let me close restream and then we'll test something out. Actually, you know what? I have an idea. Enable text to speech. Let's go.
Luther. Okay.
All right, I already figured out how to fix it. So I just have to turn on text to speech, but I have to turn off the volume so you guys don't have to hear it. All right, try texting something to me now. You guys should pop up on the bottom right. And then we can continue. And good morning, by the way, Luther. My girlfriend is sleeping right now. Okay, I didn't get a message yet. Nothing yet. Okay, I saw that. Un otro. One more. One more just to check. Alright, let's pretend I'm coding. I'm coding right here. I'm coding, and then Luther's gonna text something, and then it should pop up on the bottom. Let's see. Okay, nothing yet. Okay, bueno. It works. We're good. Now, I am probably gonna need a moderator. If anybody watches this video in the future, let me turn off restream chat. Let me see. So if anyone's interested in being a moderator, what that means is that if someone negative comes into the stream and tries to disrupt our learning process, I'm gonna give you the power to just time them out. You can go easy on them. You can time them out for like 1 minute or 5 minutes. But if it gets really bad, then you can go ahead and just ban them out. Just remove them from the party completely. But yeah. But we should be good. Stuff like that doesn't happen all the time. So, what are we going to do this stream? We are going to talk about the object detection that we were doing yesterday. We're going to go a little bit more in depth on it. Power moi. Yeah, I think I could make people moderator. I don't know how. There's a way to do it. I think I would have to go to my YouTube channel. If you guys are interested in becoming moderator on my stream, DM me on Twitter. My Twitter is at GenesisGir. And yeah, shoot me a message and be like, yo, I want to be a moderator. But you have to be a regular. The only person like eligible to be moderators right now is Mrs. Genesis and Luther, because they're regulars. I kind of know what they're like. I trust them. Yeah. So I have to know you for at least 3 days. Then you can be moderator. Okay, let's close this. Okay. Okay. There we go. That's how that works. Would you like to configure project GitHub? Not now. Configure projects on opening. Not this workspace. So, I'm going to explain to you guys. We're going to talk about object detection again. This time not getting interrupted. And if we do get interrupted, then I'll take care of it, guys. Don't worry. So you can see we have to restart this. Ladies and gentlemen, you are looking at how object detection works. You are looking at the inner workings of how object detection works. From the left, you see that we have this layer. Artificial intelligence works in layers, and anything that I tell you guys, I've studied it. If I don't know something, I won't ever speak on it. I think you guys have caught that on stream. Like sometimes I won't say something. Like, my girlfriend one time, she was like, "Oh well, what does this do?" I'd be like, "I don't know," but I know enough to tell you guys about this. In artificial intelligence, in the matters of object detection, there are layers, convolutional layers. Inside of these convolutional layers, there's an architectural intricacy that's going on, an architecture forming within these layers. I don't know the process. Oh yeah, it is 3 in the morning. Yeah, no, that's fine. I'll catch you later, Mr. Luther. Yeah, go ahead and check out the replay. It'll be there. I might stream for like 2 hours, 3 hours, who knows. Yeah, but thank you for stopping by, Luther. I appreciate it. I have a lot of cool stuff to show you when you come back. I'll make sure to put enough cool stuff inside of the stream. Alright, I'm gonna say goodnight to Luther. Excuse me, everyone. Okay. Yeah. I'm not sick. I just feel like my throat was just hurting a little bit, but I'm good. Make sure to get some sleep. I am hungry though. Fuck. All right, bye-bye. Okay, so back to this. So, as we can see, we have a classifier, and there's 4 classes, it says. And these convolutional layers do the processing of the image, of whatever input it is. For an example, all this stream, we're going to be studying on object detection, reading documentation. Yeah, take that. We're going to read documentation because we got it. That's the way we input data, you know? We're going to read documentation. We're going to implement the things that we've learned. And we're going to see the results of the things that we learn, right? You really want to truly understand how this works? You got to get in there. But ladies and gentlemen, this is the classifier known as SSD. SSD is a pre-trained detection model. It stands for single shot detector. It is one of the lower class detectors, but it works fine, you know? The one that we're going to be working with, I don't know, maybe this entire stream, we might actually try every single detector that there is that we can get our hands on. I got YOLO to work. I'm pretty sure I can get some other ones to work. I couldn't get Gluon CV to work. The download was really hard, but we'll see if I can get my hands on that. Yeah. With that said, this is a single shot detector, and we have the first layer, which takes an input, an image, a video, doesn't matter. This first layer is responsible. It is a convoluted layer that is so intricate and has its own things and inner workings. We're not going to go deep into that. It's complex. This next layer, we have the convolutional layer, conv 5_3 layer. Again, it's building an architecture here. It's doing architectural things. It's building, it's making the best thing you can think of this. It is trying to make sense of what the image is. It's trying to find the algorithms. It's trying to find what it's searching for at this layer. Does that make sense? So these layers, the jobs of these layers, we got one. We even have this one. We have 1, 2, 3, 4, 5, 6, 7, 8. I think, yeah, these layers are detecting, and it's breaking it down. The best way we can put it, it's breaking it down until it gets the result that it needs. Okay, on to the next one. We have YOLO. YOLO is another machine learning detection model as well. YOLO v3 has predecessors, which are version 1 and 2. They're not as strong as version 3, so my advice to you guys, if you want to use YOLO for image detection, video detection, use version 3. It's probably the best version that you can use right now. So that's YOLO. Moving on to the next one, we have RetinaNet. RetinaNet is very, very strong. I mean, they use this for satellites. Okay? That's how cool this is. And as you can see, it doesn't follow the same systems as its predecessors, as its other competition. It uses an entire different system going on. I think it goes from the bottom layer is the input, and it goes up and up, and then it does this type of thing. Yeah, so that's that. With that said, we are going to open up the Obsidian Vault that I have for OpenCV. We're going to close all these. Close all. So this program that you guys see me using right now is called Obsidian. It's probably one of my favorite note-taking softwares to date. It's so good, right? And let me just say this right now. I'm not going to be talking all stream. If I have something to explain, I will say what I have to say. If you guys want to come in and ask me questions or teach me something new, I'm open to that, you know? So, Obsidian is a note-taking software that's free. You can find it on Google. I'm actually not going to link it because I've disabled chat relay. So everything that's going on right now is completely live. So everything that happens right now is not being recorded. I don't think it is. At least I don't think. But as you can see, there's these little nodes here. And each one of these nodes contain information that I've compiled myself and found. And I put it here to study. You know? They're little notes that I take down. And they all have different things, different information, explaining different things. Let's say if I want to learn about what an SSD is. What is SSD? It goes really in depth here. The single shot detector for multi-box prediction is one of the fastest ways to achieve a real-time computation of object detection tasks. While the faster RCNN, which stands for regional, it stands for regional neural network. I don't know what the C is. I forgot. Let me see if I remember. Here, we can go over there and go check. I do know it stands for regional neural network, but the C I forgot. Let's see. Appreciate detectors. Regional convolutional neural network. That's what that stands for. So RCNN is another pre-trained detector, and it is a... It stands for region-based convolutional neural network. But we're going to start right from the beginning, right? In this stream, I'm going to explain what CV2 is. I don't care if we have 50 million... It's not going to take us 50 million streams, but there's going to be a lot of streams talking about object detection. And I'm starving, guys. I want to go get some food. If you're watching the stream, I'm actually starving right now. Believe it or not. Yeah. So, OpenCV. What is it? OpenCV allows you to image process and video process data. It deals with tracking. It deals with object detection, histograms, a lot of things like that. It's very, really cool. We're not going to read the whole documentation. I'm just going to tell you guys what it pretty much does. It's capable. It's a huge arsenal of a lot of things. You know, we're not going to get too in depth in it, but it's a huge arsenal of a lot of capabilities. But for the people who really want to read the documentation, we'll read it. OpenCV, which stands for Open Source Computer Vision, is a popular computer vision library that provides a wide range of image processing and computer vision algorithms. OpenCV can be used with various programming languages, including Python, C++, and Java. OpenCV Python is the Python implementation of OpenCV library, which provides Python bindings to the OpenCV C++ library. Hold on, guys. I have to... My girlfriend's sleeping, so I have to, like, mute her. There we go. It allows developers to use OpenCV with Python to perform various computer vision tasks, such as image and video processing. Like I said over there, like I said before, feature detection, object recognition, and more. OpenCV Python is free and open source. It is widely used in research and industry for developing computer vision applications. Also, OpenCV can be implemented with robotics too. So, have you guys ever wondered how some of those robots can actually detect walls, detect if there's another robot, or if there's something in front of it? This is due to object detection and feature detection. This kind of helps out how it works. So, in a way, object detection should be in your arsenal as a programmer. You should definitely learn this shit. It's really, really important to learn. Let's go on to the next one. Let's talk about neural networks. I'm doing this one again because I got interrupted last stream, and I promise if we do get interrupted again by someone, we'll just make them go bye-bye. That's it. And we'll continue. Give them a little pat on the head, and then we'll, if they keep going, then we'll banish. So what are neural networks? A neural network is a computational model inspired by the structure and functioning of the human brain. So it's inspired by how the human brain works. Crazy, right? If we look up, how does the human brain work? The human brain has neurons that transmit data with electricity, right? Let's see if I knew that. Let's ask ChatGPT if I was right about that. Does the human brain contain neurons that transmit data in the form of electricity? Yes, the human brain contains neurons that transmit data in the form of electrical signals. Neurons are specialized cells that are fundamental to the functioning of the nervous system, including the brain. They communicate with one another, with other cells through electrochemical signals. So it's not like electricity as like a car electricity. It's more so like it's a chemical electricity, which is very interesting. Like, how amazing is that? That's how it works, The basic unit of a neuron is a nerve cell, right? Which consists of three main components: the cell body, the soma, the dendrites, and the axon. The dendrites receive signals from other neurons, and the axon carries signals away from the cell body. The axon is responsible for transmitting electrical impulses, known as action potentials, over long distances. The electrical signals in neurons are generated by the movement of ions, such as sodium and potassium, across the cell membrane. When a neuron is at rest, there's a difference in electrical charge between the inside and the outside of the cell, known as the resting membrane potential. When a neuron receives a signal from another neuron, this resting potential can change, leading to the generation of an action potential. And as we know, action potentials are, the signal being sent, right? Right, the transmission of data, the transmission of this electrochemical signal is the action of actually, sending a signal to another cell is called an action potential, right? An action potential is a rapid change in electrical potential that propagates along the axon of a neuron. It is initiated. What does that mean? So an action potential is a rapid change in electrical potential that propagates. Let's see what this word means. What does propagate mean? Propagates mean to propagate, to breed, to grow, to cultivate, to layer, to pipe. It sounds wrong. Along the axon of neuron. So, as you can see, we don't have to read the whole thing. This is actually very interesting because we're not in this field right now. But that's how artificial intelligence in a way works. It has artificial neurons. It kind of like the best way to put it. It simulates what a human brain works like. How amazing, right? And it is now 3:40 a.m. in the morning right now. If you're watching this stream right now, congratulations. You're really into programming. And you're probably going to learn something every day on my stream. Don't fret. If this stuff seems very confusing to you, it's because it is confusing. But if you allow yourself to open up your mind and learn, because at the end of the day, we're just trying to understand. We just want to understand, you know? There's nothing wrong with trying to understand. You understand me? So, stick with me here. If this stuff seems really complicated, it's okay. It's my first time too. And we'll slowly get there. So, a neural network, in a sense of a computational model. The basic building block of a neural network is the artificial neuron. And, right, it just, just by looking at this, so the basic building block of every neural network is the artificial neuron. Is it possible to code? How are artificial neurons created? How are artificial neurons created in the sense of programming in Python? In Python, you can create artificial neurons by implementing a simple mathematical model that mimics the behavior of a biological neuron. One common model used for artificial neurons is the perceptron. Perceptron. What is a perceptron? What is a perceptron? A perceptron is a fundamental building block of artificial neural networks. It is a simple mathematical model of a biological neuron and serves as the basic unit for learning and making predictions in machine learning. Wow. How amazing is that? The perception takes multiple inputs, each multiplied by the corresponding weight, and sums them up. It applies an activation function to the weighted sum to produce an output. The activation function determines whether the perception fires, produces an output, or remains inactive. Mathematically, the output of an perceptron can be represented as followed. Activation function. Okay, so this is what that looks like. In this equation, the weighted sum of the inputs are multiplied by their respective weights. So there's a weighted sum, right? We're not going to get too deep into this, but we're going to copy this and we're going to go paste this so we can study it later. Because all this has a lot to do with it. So a lot of people are like, oh, well, how does this work? right? Let's see. Let's see if there's anything else that we can gather. Okay. Biological neurons. This all tails together. It's all coming together. All of it. Yes, give me all that information. We will study this later. So this right here is how a biological neuron works. We're not going to read it right now. It's not important. Just all you need to know is these fundamentals. Is that biological neurons have a structure. They have dendrites, they have the cell body called the soma, and they have the axon. And here, let's actually look up biological neuron images. So this is what they look like, right? This is what neurons look like. Oh my god, that's so cool. So here, to open this up, we have the dendrite, which is like the ends. We have the input points equals synapses. Input points, so these points are called the synapses. And then we have the axon trunk, the soma, the cell body, axon terminal. It's very, very, very complex. Okay. So what you guys are looking at right here, you're looking at an image of a neuron, of a biological neuron, right? This one's a little bit more simpler. We're going to download a bunch of them. So here we have the soma. This is the cell body of the neuron. Then we have the axon. We have the dendrites, which are these branches. I'm thinking that are the branches, right? These things that are sticking out of the soma, the cell body. These are the dendrites. And I think the dendrites are responsible for sending that electrical, chemical signal to other neurons. So it just shoot out the little corner, the little points. And then we have the axon. They didn't tell us, ChatGPT didn't tell us about axon terminals, but that's interesting. Okay, let's go. Just getting your feet wet, right? Don't feel like you have to understand this. All you need to know is this is what's constantly going on in your brain right now. This is the model of a biological neuron. This is how it works. This is the mechanism of how we transmit data. And it's with neurons. So what does that have to do with code? Because artificial intelligence uses a system like this. Most people think that it's just logic. In a way, yes. But we're making a mock type a mock-up, a genetic makeup, an artificial genetic makeup of a biological neuron. And we're trying to reverse engineer that and create that and actually do that. And we've done it. So we're gonna put that away. Let's try not to focus on things. Let's go back. And let's actually take a pic. This image is pretty bad. Let's grab this one. See if we can find another. And here's another image of neurons. Here's the axons. I think the axons are connected, are interchangeably connected together. So the electrical charge, it's not sending through like the air or anything. Like it's not, you know, airborne. The charges, it seems to be, by looking at this, are being sent through these axons. Are all of the neurons connected with one another? I'm not sure. We'll get into that. But that's interesting. Look at that. You can think of the yellow as the electricity, as the data being sent. The signal being sent to other neurons. Let's go try to find an illustration. Here's a structure, right? We have the nucleus. This is way more. This is way better. I like this one. Close all this. Okay, so right here, we're going to copy this image. I'm going to save this image. We're going to go back over here. Let's make a new folder. Let's call this downloads. Let's collapse this. Okay, now we got this here. Hopefully you guys can see that. So let's actually examine how this works. Now, the reason why we're breaking this down is so we can better have an understanding of how artificial intelligence and object detection works in a way. Now, it's so strange, right? You're probably sitting there as a programmer and sitting there. Wow, this is stuff that has to do with humans. Correct. It does. But it also has to do with how computers work as well, too. Certain aspects of computers work in a sense of artificial intelligence. So, if we look at the word artificial intelligence as a whole, what are we getting? Remove artificial just for 1 second. What are you getting? Intelligence. What is intelligence? Intelligence has to do with the brain, right? You know? So, when we add that artificial to it, it's now man-made. Let's go look up what artificial actually means. What does the word artificial mean? The word artificial refers to something that is created by human beings, as opposed to something that occurs naturally. It is the opposite of natural and organic. It is created by humans. So, a good example of something that is artificial are water bottles, right? Water bottles are man-made. We created them because, everything that you're looking at right now, we're not speaking about the water. We're talking about solely about the bottle itself. The bottle itself contains water that is natural. That is a natural element of the world around us, right? But the bottle itself, it's man-made. It's metal, it's metallic, it's made out of plastic. It's artificial, right? So when we talk in a sense of what is artificial intelligence, what we're really saying is a man-made product. And if you want to get really deep into this, ladies and gentlemen, go get yourself some food right now. Things are about to get really interesting. Artificial intelligence is all around us. It's inside of our computers. It's inside of our phones. It's inside of our web cameras. What you're using to actually watch the stream right now probably contains some artificial intelligence. And what if I told you some of those systems that are implementing that actually contain artificial neurons? That's right. Some of the technology that you're using right now actually contain artificial neurons that are just as similar, if not the same exact copy, as the human brain. Now, there are parts to a neuron, right? By just looking at this, there's a nucleus, there's a soma, there's a dendrite, you have the dendrites, you have the axons, and you have the myelin sheath. We have the myelin sheath, and it seems as here we have the Schwann cell. So these are these little purple parts. You guys see these little purple parts? The purple circles are called the Schwann. I don't know how to say that word. Schwann cell. And then you have the nerve endings to one. So these little circles at the end, these are the nerve endings. But listen to me. This is really important because if you think about it, all of this comes into cohesion with how artificial intelligence works. All of this comes into play, right? So it's astonishing. It really is. And I'm going to see during the stream if we can make our first, I highly doubt it, maybe we will make our first neural network. A small, let's ask ChatGPT if it's possible. Is it possible to create a neural and could a beginner learn how to make the simplest one possible to explore the world of artificial intelligence? So here's the question that we asked. Is it possible to create a neural network in Python? And could a beginner learn how to make the simplest one possible to explore the world of artificial intelligence? The answer is yes. It is definitely possible to create a neural network in Python, and beginners can learn to make a simple one to explore the world of artificial intelligence. Python is a popular programming language for developing neural networks and other machine learning models due to its simplicity and rich ecosystem of libraries and frameworks. Some popular libraries for building neural networks in Python could include TensorFlow, Keras, and PyTorch. To get started making a simple neural network in Python, you can follow these steps, right? We can do neural network, what is this called? In Python. Let's go ahead and copy this. We could, I think this deserves its own, vault, to be honest. Okay, but we're not going to get into neural networks right now with that. We want to focus on object detection. Let's not focus on how it works so much, but let's focus on okay. So we're going to come back over here. So where do we leave off? Neural networks, right? So the basic building block of a neural network is the artificial neuron, also known as the perceptron. Each neuron receives one or more inputs. So I want you to imagine that. In programming, neural networks can receive one or more inputs, which are multiplied by corresponding weights. Okay, so let's see what these weights are. What are corresponding weights? What are weights in the sense of artificial? Let's go ask that. That's a good question, right? Because as we know, these neurons get like input, right? So neurons can get like receive one or more input, and then those inputs are multiplied by corresponding weights, right? So let's ask ChatGPT what are corresponding weights in art. And what are their purpose? So this is the question that I asked. What are corresponding weights in artificial intelligence, and what are their purpose? In the context of artificial intelligence, corresponding weights refers to the parameters associated with the connections between artificial neurons or nodes in a neural network. Neural networks are a fundamental component of many AI systems, and they are designed to mimic the behavior of the human brain to some extent. Some neural network in a neural network, each connection between neurons in a neural network, each connection between neurons has an associated weight. These weights represent the strength or importance of the connection between the two neurons. They determine how much influence the input from one neuron has on the activation of the next neuron. So it depends on the strength and importance. So corresponding weights determine the strength and the importance of the connection between two neurons. That's what we know so far. During the training phase of the neural network, there is a phase. The weights are adjusted. How do you say this word? Let's see. Excuse me. Pronunciation.
Iteratively.
How do you?
Iteratively. Iteratively.
Iteratively. I know this is iteratively. Iteratively.
Iteratively.
Yeah, iteratively. So iteratively. That's a hard word. That's a really hard word. Especially if you're Spanish like me. So iteratively, based on a process called back propagation. And we know propagation means to propagate is to breed, to birth, to create, right? So there's this phase called the training phase of a neural network, and the weights are adjusted iteratively based on a process called back propagation. The network learns from example data, comparing its output to the desired output, and using an optimization algorithm such as gradient descent to adjust the weights. So the AI starts making comparing the output that it has and the desired output that it wants to have, and it does this through gradient descent using the adjusted weights. The goal is to minimize the difference between the network's predicted output and the desired output, known as the loss or error. By adjusting the weights, the neural network can learn to recognize patterns, make predictions, classify data, and perform other tasks based on the given input. The weights essentially encode the learned knowledge or information within the neural network, allowing it to generalize from training examples and make accurate predictions on new or unseen data. Wow. That's insane. Allowing the neural network to generalize from the training examples and make accurate predictions on new and unseen data. So data that hasn't even been rendered yet. The purpose of the corresponding weights is to provide the neural network with the flexibility to adapt its behavior and learn from the data it is exposed to. By adjusting the weights, the network can assign different levels of importance and strengths to build to different input features. In summary, corresponding weights in artificial intelligence are parameters associated with the connections between artificial neurons and a neural network. They determine the influence of one neuron's output on another and are adjusted during training to optimize the network's performance on a given task. The weights encode learned knowledge. So encoding, what does encoding mean? To set a format and allow the network to generalize and make accurate predictions on new data. Okay, corresponding weights. Or you can just say weights, period. Well, we're going to say corresponding weights because that might be its own thing. Mm-hmm. Okay, so we learned about corresponding weights. Okay, these weighted inputs are then summed, and a nonlinear activation function is applied to the sum. A nonlinear activation function. So after the weights have made their determination of what, have summed up, the weighed inputs are then summed. A nonlinear activation function is applied to the sum too. The output of the activation function becomes the output of the neuron and is passed on to the next layer of neurons. Okay. So what I'm seeing here is that so we start off with the perceptron. This perceptron receives the neuron. The artificial neuron receives input. It gets these inputs. After it receives these inputs, it goes through the data. It transfers the data to other neurons, but there's these corresponding weights between each neuron, and these neurons, the corresponding weights are testing the importance and the strength of the data that's passing between them, right? That's really interesting. So these weights are really an important factor to how it works. But let's keep reading. Neurons are organized into layers in a neural network. The input layer receives the initial data. We know that, like an image or whatever it may be, while the output layer produces the final results. In between the input and output layers, there can be one or more hidden layers that perform intermediate computations. Neural networks with multiple hidden layers are known as deep neural networks. So if there's hidden layers between the other layers, it's a deep neural network. And they have shown remarkable success in various complex tasks. During the training phase, neural networks learn from labeled data by adjusting the weights. By adjusting the weights, this is making sense of the data of everything that's going on. So it compares the output to the desired output. That's what's going on. It's adjusting these weights, and the corresponding weights are checking to see. They're comparing the original the output that outputted and the desired output, and it's constantly changing. That's amazing. That's how that works. And then we have this process is known as backpropagation. No, we already read that. Okay. Uses optimization. Okay. During the training phase, neural networks learn from labeled data by adjusting the weights and biases. How do you say this word? Biases? Bias? I know it means bias. I don't know. Bias. Yeah, so that would be biases associated with each neuron. So a bias is prejudice, a favoritism. Oh, look at that. It's a disproportionate weight in favor of or against another idea or thing, usually in a way that is close-minded or unfair. Okay. So during the training phase, the neural networks learn from labeled data by adjusting the weights and biases associated with each neuron. This process is known as backpropagation. So the adjusting of weights is called backpropagation. Uses optimization algorithms to minimize the difference between the network's predicted outputs and the expected outputs. By iteratively adjusting the weights, neural networks can gradually improve their performance and make accurate predictions or classifications. Overall, neural networks provide a powerful framework for modeling and solving complex problems by leveraging their ability to learn and generalize from large amounts of data. So that's what a neural network is, right? I went really in depth on that. Give me 1 second. My loves, I'm muted because I'm sitting here streaming, so give me 1 second. Okay, I'm back. So, yeah, we went really in depth on what neural networks are. This is GenesisGir. We are now about to hit 420 now. I've learned about neural networks, and what I've learned about neural networks is really astonishing. I've learned that neural networks work off of electrons, and these electrons, not electrons, I'm sorry. Let me start that over. I'm sorry, I'm tired. I've learned that neural networks work off of neurons. They have neurons. These neurons contain a cell body called the soma, dendrites, and axons to transmit data, information. And that the electricity that it's transmitting in the signal is not actual electricity that we see in cars and whatever. It's a chemical electricity that it's transmitting. And that the neural network inside of a human brain has a lot to do with how neural networks work in artificial intelligence. So that is what I've learned. And that inside of an artificial neural network, there are corresponding weights. There's artificial neurons. There are biases. There's a lot of stuff that it goes through processes like back propagation, all that stuff. So let us continue learning about object detection. This is in the topic of object detection. So what is non-maximum suppression, or better known as NMS? NMS, let's read on it. All right, so pretty much non-maximum suppression is, long story short, it reduces the amount of bounding boxes that can be found in a detected final prediction output, right? So it just reduces the overlapping bounding boxes. So if something is not we found that in another image that we were working with. There was a horse nowhere to be found in the image, but there was a bounding box over a fireman. And I think we may still have it. Let's go take a look to see if we still have it. Go to data. We go to darknet. We go to predictions. And we can see here's the image I'm talking about in question. So what NMS does, which means for non-maximum suppression, it'll try to reduce the bounding boxes over a certain it stops overlapping as much as it can. Let me try this again. Non-maximum suppression reduces the overlapping of bounding boxes to a detected entity, whatever it is. You can see here we have a person. It knows that. It has a backpack. It knows that. A person, backpack. But over here, it thinks that this is a horse for some reason. Weirdly enough, this is what we mean by, as you can see. So we got person and we got horse. So what NMS does is try to reduce what's going on here to the left. So if that makes any sense. So long story short, non-maximum suppression was created to reduce the overlapping of bounding boxes. Great. We can move on to object detection algorithms. Let's see what's here. We have a lot to read here. Oh no, I already read this. Perceptron. Okay. So let's read on perceptrons. See what they look like. Perceptron definition. Look, it's like a layer thing going on too. Output signal. Feedback circuits. Topographic connections. Random connections. Mosaic of sensory points. We have, look at this. Let's go take a look at this right here. This is the organization of a biological brain. The red areas indicate active cells corresponding to the letter X. Is it really that letter X? And figure number 2 is the organization of a perceptron. Okay, so perceptrons seem to have this type of shape going on. So what is a perception? Perceptron, a beginner's guide. Weighted sum. So here are the weights. Here are the inputs. We have X and X. So these two are, these three, let's see, are the inputs. We have 1, 2, 3. And it seems as these weights will eventually be the amount of the weighted sum. This weighted sum goes through this step function. So let's go ahead and copy this. Call this weights. G. We could use a better image. It's not a good image. Is it possible to build a perceptron? Yeah, they even go in and talking about its inputs and its out.